Hi, let's continue our discussion of this sequential circuit. And We are trying to analyze how this sequential circuit works. And let's continue doing that in a more kind of uh, detailed manner by writing a truth table. Okay. And what I have done in this truth table for now is that what I've said is uh, we have defined what the present state of the circuit is. And the present state, as I said before in the previous video, is defined by X and Y, right? The two outputs of the D flip-flops. Uh, and at any instant of time, you're also getting an input A in your circuit, from your circuit. And depending on what X, Y, and A are, you will be getting the next state of your circuit, right? Once the clock signal arrives, the state of your circuit is going to change, and that's going to be the next state of your circuit. And also, depending on the present state and the input you will be getting an output. And I'm not sure why I have written two outputs here, but there's only one output, right? So you get an output here. Okay, so let's try to figure out how we can get how we can analyze this circuit. And the basic idea in the truth table is that what I've done is I've written all the combinations of the present state and the input here. So because this is 3 bits, you have 8 combinations. Okay, now let's take a look at to how this circuit works. So so X and Y, let's say they are 0 and your input is also 0. Okay, so let's take a look at this circuit then. So X is 0 and Y is 0. So let's start with X equal being 0. So if X is 0, so what are the inputs to this particular OR gate? So if you look at that, X is 0 and the other input is coming from Y. Y is also 0, so both are 0. So the value here is going to be 0. If that is 0, so if any one of the inputs of the NAND gate is 0, what do you get at the output? You get a 1. So you get a 1 here. Okay. If you get a 1 here, what is going to be the next state? So after the clock signal arrives, what will happen in a D flip-flop? Well, the output is going to become 1, right? So X is going to become 1. So let's put that in. So next state in your X plus is going to be 1. Okay. What about Y plus? So let's try to figure out. So to get Y plus, to get the next state of Y, we need to figure out what is the input that comes here. So here, what are we getting? We are getting an input from X bar, right? So which is going to be 1 because X is 0. So this is going to be 1. And you're also getting an input which is going to be 0. So 1 and 0 odd gives you 1, and therefore your output is again going to be 1 here. So your Y plus is 1 as well. Okay, so what's the output then for this state when X and Y are 0 and A is 0? So again, if you look at this circuit, the value here is going to be 1 and the value at this point is going to be 0, right? A is still 0 and Y is 0, so Y bar is 1. So you're doing an exclusive OR of 1 and 0. And the output is at that point is going to be 1. That's right. So let's put our output also as 1. Okay. So hopefully that makes sense. So let's do another output. So let's say you have 0, 0, X and Y are 0, 0, and your input is 1. Okay. So so here X is 0, Y is 0, and your input A is 1. Okay, so if Y is 0, so what are the inputs to this OR gate here? The inputs are 0 and, oh, I'm sorry, 0 and 0. Yeah, so this is going to be 0 here. Now if this is 0, you know that this is going to be 1 because this is a NAND gate. If one of the inputs of the NAND gate is 0, you get 1 at the output. So you get a 1. So X plus is going to be 1. So let's note that down and in this table. So x plus is going to be 1 still. What about y plus? What happens to y plus? Let's take a look at that. So you have this OR gate setting, giving you this D input, which is going to determine what y plus is going to be, right? So the inputs to that is 1 and 1, because the input is also 1. So 1 and 1 give you 1, and therefore y plus is also going to be 1. Okay, what about the output? So if you want to get the output, you need to find out the inputs to this XOR gate, and the inputs are going to be 1 here and a 1 here. So 1 and 1, which gives you a 0 for an XOR, right? So you get an output of 0. Okay, and you can continue on this process and you can fill up this table. What I'll do is below this video I'll give you the final truth table, but I think as an exercise you can work out all the combinations of the inputs that you should get for the circuit.